there's always a little more to be said. So I'm going to go ahead and say it. This is going a little deeper, but not so deep that you can't really understand it if you think about it. You won't be able to understand it in the sense of being able to do a sophisticated proof of it, but the idea is one that's worth thinking about and one that is should not be beyond you. Okay? So now, if we have a dense set of constructed points in the circle, it's clear that if we construct all the corresponding points here, we'll have a dense set of points on the graph. Okay? But since there are points on the circle that can't be constructed, there have to be points on what we want to think of as our sine graph that won't be within that dense set. Okay, the set might be dense. It is dense. We've kind of proven that it's dense, although I'd love to see you write out a more detailed attempt, at least, to prove it. The point is then that, well, what do we mean by the real sine graph? We want the sine graph to include even the points that we haven't been able to construct. Okay? So what I'm going to do is I'm going to just say that the sine graph is the closure of the set of constructed points. And the closure means all the points in the whole entire plane that haven't been constructed, but such that in some little circle around that a given point, there are infinitely many, I'm sorry, I said in some circle, in every circle around that selected point, that non-constructible point, there are infinitely many points of the dense set. Okay, so that although we can't construct square root of 2 over 2 times the circumference, that point will not be constructible on this axis. It's not constructible on this graph. I can say that there will be, for any small circle around a certain point that lies at the point here corresponding to square root of 2 over 2 times the circumference, and that point would be somewhere around about here, not around about here. No matter how tiny you want to make that circle, again, the circle having a center corresponding to this horizontal position, no matter how small you want to make that circle, there will be infinitely many points of our constructed dense set. Okay? Then that point lies on the graph. And if that is our criterion, every point that satisfies that criterion lies on the graph, and that's what we mean by the closure of this graph.